SpaceX is on a relentless mission to push the boundaries of space exploration. But their journey hasn't been without its challenges. After a devastating anomaly with Ship 36, which left their Masseys test site in ruins, the company is now racing to rebuild and innovate. But here's where it gets fascinating. As they prepare Ship 38 for static fire testing on Pad 1, SpaceX is not just restoring what was lost. They're upgrading their infrastructure to prevent future disasters. And this is the part most people miss. These upgrades aren't just about safety. They're about scaling up for the ambitious Block 3 and beyond. Following the incident that destroyed the methane tank farm and damaged the static fire stand, SpaceX has made remarkable progress. Crews have nearly completed the rebuild of the methane tank farm, introducing a new horizontal tank to increase storage capacity. But here's the controversial part. Some critics argue that these upgrades, while impressive, may not fully address the root causes of past failures. What do you think? Are SpaceX's efforts enough, or is there more they could do to ensure safety? One of the standout improvements is the use of SpaceX's own valve skids for both liquid oxygen, LOX, and liquid methane, LCH4 systems, first seen on Pad 2B. These modular designs are now being rolled out across all tank farm systems, making maintenance easier and more efficient. Additionally, a new box fan vent has been added to dilute liquid nitrogen, LN2, from the LOX subcoolers, a feature that could mitigate risks in future operations. To protect against another explosion, SpaceX has buried cryolines for LCH4 and LOX systems in a new trench, leading to a concrete fluids bunker. Only the lines connecting the bunker to the ship umbilical structure will remain exposed. But here's a thought-provoking question. Could this underground design introduce new challenges, such as maintenance difficulties or undetected leaks? Meanwhile, the rest of Masseys is buzzing with activity. The Block 3 booster aft test tank, B18.1, recently completed its 10th cryogenic test. Though a potential failure in the horizontal actuator, while this project has faced slight delays due to concrete pouring issues, SpaceX isn't in a rush. There are no Block 3 vehicles ready for testing yet. The new booster cryogenic test stand is ready for Booster 18, and the ship thrust simulator stand is undergoing work in Sanchez. Over at the production site, Gigabay construction is nearing completion, with 7 out of 10 concrete pours finished. Tower cranes are expected to arrive soon, marking the beginning of the steel beam assembly. Once complete, SpaceX can move on to Block 4 of Starship, stretching both the booster and ship. But here's where it gets controversial. With Starbase's progress almost matching the Gigabay construction in Florida, some wonder if resources are being spread too thin. Is SpaceX biting off more than it can chew? On the vehicle front, Booster 18's aft section was finally rolled into Megabay 1 on September 19 and stacked the following day. This milestone allows SpaceX to complete the LOX tank and move on to the methane tank with the new integrated hot stage truss. Meanwhile, Ship 39 remains in the Star Factory, where its heat shield is being completed for the stacked nose cone and payload bay. A test tank is also waiting in Megabay 2 for potential Block 3 ship aft testing. At the launch site, Pad 2B is nearly complete after 18 months of construction. Shielding now covers over half of the service structure, and high-pressure, cryogenic, hydraulic, and electrical components are almost installed. SpaceX recently conducted 4 tests of the flame trench deluge systems, using sump pumps to recycle water for future activations. But here's the part most people miss. While Pad 2B is almost ready, Pad 1A still needs significant upgrades to handle Block 3 and beyond. Ship 38, mounted on Pad 1, has faced 2 aborted static fire attempts. The first was due to a makeshift umbilical plate issue, while the second may have been related to the ship itself. With 2 new closures scheduled for September 22nd and 23rd, crews might attempt a 6-engine static fire to expedite flight readiness. But here's a bold question. Is SpaceX rushing these tests to meet deadlines, potentially compromising safety? Looking ahead, Flight 11 will mark the final flight of Block 2 and the last launch from Pad 1A in its current configuration. To accommodate Block 3 and future iterations, SpaceX needs to upgrade the pad and develop on-site liquid methane generation capabilities. This requires permission to build on wetlands, tidal flats, and uplands south of the current launch site, property SpaceX has owned for years but hasn't been able to develop. The United States Army Corps of Engineers, USAC, is currently reviewing SpaceX's proposal, which includes adding a new water deluge system, isolation and purging systems, and expanding the tank farm. The plan also involves building liquid natural gas liquefaction plants and LCH-4 generation facilities, enabling on-site production of LN2, LOX, and LCH-4. But here's the catch. The proposal doesn't require an environmental impact statement, raising concerns about potential ecological consequences. Should SpaceX be held to a higher environmental standard? If approved, construction could begin by early 2026, pending the acquisition of land swap credits. This massive expansion would not only support SpaceX's ambitious launch cadence, but also reduce reliance on external resources. But as we marvel at SpaceX's progress, let's not forget to ask, at what cost? What are your thoughts on the balance between innovation and environmental responsibility? Share your opinions in the comments below.